All right, so by this point, you've learned to solve quadratics using two methods, either factoring or square root. They are both great and work in certain circumstances, but not all. So for instance, if we look at this warm-up problem here on the kind of middle of page 74, we'll see that we definitely couldn't use the square root property because I have this x term, so that square root property won't work. So then if I try to factor, because that's the only other way that we know how to solve, factoring with a number greater than 1 in the front means I'm going to figure out the factors of 2, which are just 1 and 2. So that means my one first term needs to be 1x, the other first term needs to be 2x. And then my only factors of 7 are 1 and 7. So that means one of these spots is going to be 1 and one of these spots is going to be 7. Now, because this is a positive 7, but they add to give me a negative 10, that means both terms would need to be negative, right? A negative times a negative would give me a positive, and a negative times plus a negative would give me a negative here. So both of my factors have to be negative. So let's say I put the 1 here and the 7 here. If I was to do my outside and my inside term, I get 1x and negative 7 give me negative 7x, and negative 1 and 2x gives me negative 2x. So then if I add those together, I get negative 9. So that can't be the right sequence. So then if I switch, right, I know that these two terms are the only two options for the front, and these are the only two options for the back term. So then that means the only other option would be if I put the 7 here and the 1 here. And if I did that, I would end up with negative 1x and negative 14x, which also does not add to give me negative 10. So at this point, I could not solve this by factoring this. These do not factor. So we need another option in order to solve, and that's where the quadratic formula comes in. So the quadratic formula is probably the most steps, kind of the longest process to come up with your answers. However, it does work for every quadratic formula that you write in standard form. So you probably remember seeing the quadratic formula from Algebra 1. So this is our quadratic formula here. A big thing to note is that your equation has to be in standard form, meaning your a term is the term in front of x squared, the b term is the number in front of x, and then that c is your constant. So you want to make sure that you have it in standard form first before you figure out what each letter represents. So for instance, if we look at number 1, it is already in standard form. I have x squared, x, and my constant. So then I can define what a, b, and c are. A is the number in front of x squared, so a would be 2. B is the number in front of our x term, so b would be negative 10. And then c is our constant, so c is 7. So then once I know the value of a, b, and c, I can just plug those in to our quadratic formula and simplify. So I get x equals negative b, so negative of negative 10, plus or minus the square root of negative 10 squared minus 4 times a, which is 2, times c, which is 7, all over 2 times a, which is 2. So all I did is I replaced each letter with the number that it represents. And now I'm just going to simplify everything until I can get down to my two answers. So my minus or my negative of negative 10, a negative and a negative are going to make this positive 10. Then solving inside my square root, negative 10 squared, negative 10 times negative 10 would give me positive 100. Remember, a negative times a negative is positive. We have to be careful. A lot of people make a mistake here about keeping this answer negative, and that is if in your calculator you do negative 10 squared, your calculator always follows order of operations. So it's going to do 10 squared first because exponents come before multiplication, and then it's going to multiply. It's going to do this in your calculator. So it's going to do 10 squared first and then multiply by negative 1. If you need your calculator to do exponents, you have to put it in the parentheses so that you know that the value is negative 10 that you're squaring. This is saying square 10 and then make my answer negative or multiply it by negative 1. So you have to make sure you're really intentional about how you square terms to make sure you end up with that positive answer. Then I do negative 4 times 2, which would give me negative 8, times 7, which would give me negative 56, and that's all over 4. So then if I keep simplifying, so I'm going to come over here, I get x equals 10 plus or minus 100 minus 56 would give me 44 over 4. So now I cannot simplify this number inside the radical with this 4. The radical locks that number in. That number is not touchable inside the radical. Now, when I simplify the radical, if something comes out, then I would be able to simplify. But where I am at now, if there's nothing, right now I have 2 terms at the top. So I have 10 and then I have the square root of 44. I cannot simplify this when there's nothing on the outside of this term, right? I can do 10 divided by 4 and simplify that. But I can't simplify the square root of 44 like it is, because all I would be able to simplify is the term in front of the square root, and right now that's a 1. So this can't be simplified yet. But let's simplify this square root, and then we will be able to. So I want to look for the largest perfect square that goes into 44. That would be 4. So the square root of 44 is the same thing as the square root of 4 times the square root of 11. Right? Because 4 times 11 is 44. But I can simplify the square root of 4, which is 2. So the square root of 44 simplifies to 2 square root 11. So that means I can replace the square root of 44 with 2 square root 11 over 4. And now, because I have a 10, a 2, and a 4, I have a term. In each term, I have something that can be simplified. I can reduce this fraction. 10, 2, and 4 are all divisible by 2. So I can divide each of these terms by 2. So 10 divided by 2 would give me 5. 2 divided by 2 would give me 1 square root 11, or just the square root of 11. And then 4 divided by 2 would give me 2. So then that means my answer is 5 plus or minus the square root of 11 over 2, which gives us 2 solutions. One of them is 5 plus the square root of 11 over 2, and one of them is 5 minus the square root of 11 over 2. So there are 2 solutions because of that plus or minus. All right, let's look at the next one together. Okay, so like we said before we can use the quadratic formula, this has to be in standard form. So considering it's already in standard form, I'm set to identify A, B, and C. So A is 9 because it's the number in front of my x squared term. B is 6 because it's the number in front of my x term. And C is my constant 2. So now that I have that, I can plug that into my quadratic formula. So I'll have x equals negative b, so negative 6 plus or minus the square root of 6 squared minus 4 times 9 times 2 all over 2 times 9. So all I did was plug in each number for the letter that it represents for my quadratic formula. So now when I solve, I get x equals negative 6 plus or minus the square root of 36. Negative 4 times 9 is negative 36 times 2 is negative 72 all over 18. So now if I simplify further, let me get some paper that I can write with. Sorry, my handwriting is too big, so it's not going to fit on the paper. So we're just going to bring it over to this piece of paper. So then if I simplify, I get negative 6 plus or minus the square root. 36 minus 72 would be negative 36 over 18. So now, with the work we did with complex numbers in class, we can identify that this 36, right, because it's negative 36, we can simplify that. The square root of 36 is 6, and then because it was negative, that answer is going to be imaginary, so we're going to have that I in that place. So my answer is negative 6 plus or minus 6i over 18, and then both of my terms at the top and my term at the bottom are all divisible by 6, so I could reduce each of these numbers by dividing by 6. So negative 6 divided by 6 would give me negative 1. 6 divided by 6 would give me 1i, or just I. And 18 divided by 6 would give me 3. So my final answer would be negative 1 plus or minus I over 3, which is the two solutions, negative 1 plus I over 3 and negative 1 minus I over 3. So those are the two solutions to my quadratic. Yeah, so if we notice, because we've got these i's in this answer, this would never have been able to factor. So the quadratic formula would be the only way that we could solve this problem since it doesn't factor. It is important that you know the quadratic formula, that you have it memorized. We will not give it to you on a test. You have to know the quadratic formula. So start memorizing it. You could look up on YouTube. There's some fun songs that sing it to you, but make sure you know that quadratic formula for class. All right, let's look at number 3 together. So for number 3, before I can start solving, this needs to be in standard form. So I've got to move everything over to this one side. So I'm going to move this x squared over to this side, and I'm going to move this 8x over to this side so that everything is on the same side of my equation. So when I do that, 3x squared minus 1x squared would give me 2x squared. Negative 2x plus 8x would give me 6x. And then I have plus 5, and now that equals 0. So now my equation is in standard form, and I can use my quadratic formula to solve. So I know that A is 2, B is 6, and C is 5. So then I go to my quadratic formula, and I plug in A equals negative B is going to be negative 6 plus or minus the square root. B squared will give me 6 squared minus 4 times A, which is 2, times C, which is 5, all over 2 times A, which is 2. So I plugged in all my values, and now I'm just simplifying. So the front will stay negative 6 plus or minus. 6 squared gives me 36. Negative 4 times 2 is negative 8, times 5 is negative 40, all over 4. So then if I keep simplifying, x equals negative 6 plus or minus the square root. 36 minus 40 would give me negative 4 over 4. And from my work with complex numbers, I can take the square root of 4. So since it's negative 4, I can still do it. That just makes my number imaginary. So I get 2i. The square root of 4 is 2. And then because it was a negative 4, my answer is now imaginary with that I. So now I have the two terms at the top and the term at the bottom that can all be divided by 2. So when I divide by 2, negative 6 divided by 2 gives me negative 3. 2i divided by 2 just gives me 1i. And then 4 divided by 2 gives me 2. So my answer is negative 3 plus or minus I over 2. If this 2 wasn't here, let's say I just had 6 plus or minus I, 1i, I would not be able to simplify. Both terms at the top have to be able to divide by something the bottom has in common. But if I had 6 and 1, 1 is not divisible by something 4 is divisible by. So it wouldn't be able to reduce. So just keep that in mind as you're reducing. Lights off, meaning we need a walk break. All right, back to it. One more example. All right, so again, let's make sure that our equation is in standard form. So I need to move this 8x to the same side of my equation. I'm going to add it to both sides. So I have 4x squared plus 8x minus 1 equals 0. So now that it's in standard form, I can identify A, B, and C. A is 4, B is 8, C is negative 1. So then I'm going to plug it into my quadratic formula and simplify. So x equals negative b, just negative 8 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So then we're just going to simplify. So this is x equals negative 8 plus or minus the square root of 64 minus negative 4 times 4 gives me negative 16. Negative 16 times negative 1 actually gives me a positive 16 here. That's 64 plus 16 all over 8. Right, I have negative, which gave me negative 16 times negative 1 is positive 16 here. So then if I simplify further, I get negative 8 plus or minus the square root of 80 over 8. So now I'm looking to reduce the square root of 80. So right now I could not divide. Remember, inside that square root, it is locked in. I cannot divide that by 8. You can only divide it when there is a number on the outside, and that's what you divide by. What is inside the radical stays untouched. If it comes out of the radical or the radical simplifies away, then I can reduce. Right here, I brought a 2 out, so that's what I reduced. The 11 stayed exactly the same. Here, I reduced so that the radical disappeared, right? I could get rid of the radical, and then I can reduce. But what is inside the radical cannot be divided by. So now, the square root of 80, the largest perfect square that goes into 80 is actually 16 times 5. Yeah, 16 times 5 is 80. That perfect square 16, I can reduce to 4. Yeah, so when I'm trying to reduce a radical, I'm looking for the largest perfect square. So my perfect squares are 1, 4, 9, 16, 25. And so 16 goes into 85 times. So if I multiplied these two back together, I would get the square root of 80. But I can simplify this to give me 4 square root 5. So now I'm going to rewrite this as x equals negative 8 plus or minus 4 square root 5 over 8. And now that I have a number on the outside, I can divide each of these numbers by something they have in common. So 8, 4, and 8 are all divisible by 4. So I'm going to reduce it by dividing by 4. Negative 8 divided by 4 is negative 2. 4 divided by 4 is 1. So this is just 1 square root 5. Remember that square root cannot be reduced. We are not touching the square root of 5. And I just literally, did you guys notice I just wrote on the desk? Whoops. All right, just finish this problem and be done. And then 8 divided by 4 would give me 2. So my simplified answer, and I'll write it all on the piece of paper, would be negative 2 plus or minus the square root of 5 over 2 as my final answer. And we'll go ahead and just clean this desk really fast. Thank goodness I used pen that will come off. But hopefully that helped you, and you can go ahead and finish your homework or your practice using the quadratic formula.